Alright guys, creating a probability histogram. I made this little table so that I don't have to waste time making it while I show you how to do it. But the way how this works is you're going to draw a horizontal line, label the number of successes on the x-axis ranging from 0 to 10 because the free throw shooter is going to take 10 shots. We're using example 2 data. The vertical bar will represent the probability of making any of these 10 shots, which we already summarized in the table on the previous page. So we're just going to go ahead and plot the value and then draw like a blow bar to represent their height. So if you look at the previous table, the probability of making 0 shot is 0. Okay, so the dot's going to be there. The probability of making 1 shot from the previous table is also 0, so there's no height. The probability of making 2 shots, it's also 0. The probability of making 3 shots is 0.003, which is really close to 0. So, and then just maybe a little bit higher, like that. Okay. The probability of making 4 shots is 0.016, and then 0.05. 0.01, think of it as 1 cent, think of it as 5 cents. Okay, so 0.01 is going to be a little higher, and then 5 cents, this is 5 cents, so like up here. Okay, and by the way, these are histograms, so you want to draw like a little like a line connecting to that dot like that. 67. 0.14, think of it as 14 cents, that's easier for you to see. 25 cents, 0.25, so 0.14, about right here. Okay, draw down, and this is about 25 cents, so sorry, I know I took up a little bit overflowing the room here, but 25. Okay, and then 8, 9, 10, let's see, 28 cents, 0.28, 0.18, 0.05. So 0.28 is going to go all the way up here. Okay, and then 0.18, if you look back on the previous page, 0.18 is going to go all the way around up here, just right below 0.2. And then 0.05 is about right here. So this would be the histogram for a binomial distribution. Okay. Alright, great. Now, generally, this graph is going to look more like a normal distribution or a bell curve graph, but because our trials is too small, therefore it looks kind of like normal over here. It looks like it's symmetric over here, but not over here. Okay. Alright, so we're almost done here. Does the table here describe a probability distribution function? Well, to answer whether or not this table represents a probability distribution function, we have to make sure that it satisfies the criteria. If you remember on the previous page, in order for a table to satisfy the criteria of being a probability distribution function, the probability in that table has to add up to 1. So we add these up, and if it adds up to 1, then we say yes. If it doesn't add up to 1, then we say no. 0.19 plus 0.26 plus 0.33 plus 0.13, that adds up to 91. So the sum of the probability equals to 0.91. No, the table is not a probability distribution function, because the sum did not add up to 1. Okay? Alright. Now, when you are given a table and you want to find the mean and the standard deviation for a given probability distribution function, then we use a different formula. And the formula looks like this. It's the mean, and remember that the mean is the expected value we take each x value, we multiply it to the probability, and then we add them up. That's how we find the mean for the standard deviation. Okay. Now to find this is how we find the mean. To find the standard deviation, we tweak the formula a little bit, which stands for the